look into using DAX, which is a data analysis expression. So using a data analysis expression. So now, before before we start the class, so I would like to show you one of the projects that I've created with DAX, to where I use a data analysis expression. So what it is opening. So while it is opening, so let me open this slide. I hope you can see my screen. So now, data analysis expression Power BI. So what we are going to look into in this class. So first one is introduction to that DAX in Power BI. So then uses of DAX, calculated columns and measure, understanding context, functions, and time intelligence calculation. So I want to show you the real application of DAX in one of the projects that I've done with Power BI. But my Power BI is still open. So now, but let's move on. So now, introduction to DAX. So DAX means data analysis expression. So it's the formula language used in Power BI that provides the ability to create columns, table, and measure. You know, in Microsoft Excel, so we normally use formulas, okay, to create a sum, a total values, maybe based on column or based on row. So or you use formula to calculate average, count, and some other formulas in Microsoft Excel. So that is the example of that DAX in Power BI. For Power BI, is more advanced than formulas in Microsoft Excel because this one you can use DAX to create another table entirely. You know, in Microsoft Excel, what you can use formulas to do is to calculate to get values, okay? Maybe to calculate a set of values in Microsoft Excel. But this one, you can use it to create another column, okay, or another table. So that formula include functions, operators, and values to perform advanced calculations and queries on data in related tables and what are columns in tabular data models. So that involves functions. Functions are sum, okay? And if I want to start writing DAX formula, so you start with equal sign as we normally do in Microsoft Excel. So you start your DAX formulas or DAX functions. So you start with equal sign, then followed by function. Okay. So function like sum, average, count, calculate, filters, and other functions in DAX. Then operators are addition, subtraction, division, multiplication. Then we have logical operators, okay, and or. Then relational operators like less than, greater than, and some other operators. So values there are values like column, okay, that you want to calculate. So maybe the values of the column you want to calculate. So now, so that is a component of DAX. That is, it involves functions, operators, and what, and values. So you need to understand that. So another thing is that it is the formula language used in Power BI Excel, Power Pivot, and SQL Server analysis services. So you can make use of DAX in all these three environments: in Power BI, in Excel, Power Pivot, and SAS. So DAX is used to create custom calculations and aggregations in other models, on data models. So you can use it to do custom calculations, to create calculated columns or aggregations. So aggregations, they are used for measure. So if you want to create a measure, so I'm going to explain the difference between calculated column and measure. So in the next slide, so that is only used in Power BI's front end, as opposed to the Power Query editor, which uses M language. So we have Power Query editor. Power Query editor is used for data cleaning. We have done that in our last class. So cleaning of data. So if you want to clean your data, you want to transform your data, you will use a Power Query editor. So, and the language that you can use in Power Query editor is M language. So we use that to create a custom column. If you check the last class, so where we did data cleaning, so we make use of M language to create a custom column. Maybe I want to convert a particular values in text, maybe text values. You want to convert from lower to uppercase. So you can use M language to do that. So M language is used in a back end of Power BI. So why DAX is used in front end of Power BI. So at least we use the DAX on the reports environment. Okay, so but if it is M language, we use it in the Power Query editor. So now, then why learn DAX? First one is enhances data analysis capabilities. There are some values that you may want to get, you may want to display to stakeholders. You may want to display on your dashboard to show the stakeholders. So if you don't use that, you may not be able to achieve that. Okay, so when you uploaded your data set, so Power BI normally detects some columns with numeric values. So and Power BI will create the sum of those values, some of those columns. Like if you have a stage column in your data set, so immediately you uploaded your data set, so Power BI will create the sum, the total values of that stage column. It will automatically created. So, but that is implicit measure. But if you want to get a total sales based on branch, maybe when you want to calculate total sales where branch equals to branch A. So Power BI will not create that one for you automatically. So you need to use DAX, okay, to create such kind of values. Okay, so we use that, so it enhances the data analysis capabilities and also allows for complex calculations and data manipulations. So it will allow you to do some complex calculations. You want to find the percentage of a particular value. Okay, so we use that to create that. So then essential for creating dynamic report and dashboards. So you can use DAX for that. Then, so we use DAX to create calculated columns, calculated tables, and measure. Okay. So calculated columns allows us add additional information to our data set that is not present in our data. So if you have 5 columns in your data set, so you can use that to create additional columns. based on the existing columns you have in your data set. So for example, let me see if this has been opened. I don't know why it's okay. So we use calculated columns to create more columns to our data set. So for example, if you have maybe cost price, then sales price, so you want to get the profit, okay, and there is no profit column in your data set. So you can use that to create calculated columns that will generate that profit column for you based on the column you have, that is cost price and sales price. So now write that you reference the column, the two columns, sales price and what are cost price. So by subtracting cost price from sales price to get the profit. So then it can be very useful as they enable us to expand our existing data set without editing the source data. So it will allow you to expand your data set so without touching the existing data set. So calculated columns evaluate at the row level and therefore has a new column to an existing table. So if you want to create a calculated column, you can only do the operation based on row level. I get it that. So you evaluate at the row level. That is, it's going to calculate the values row wise, okay, to generate the column. So that is for calculated column. Another thing that you need to understand about DAX is that you cannot reference cell, individual cell, when you are writing your DAX. You know, in Microsoft Excel, if you want to write a function, you reference as some cell, okay? Maybe you say equals to sum into bracket A1 to maybe B3, for example. You cannot do that in DAX. So what you can do is to reference a particular column. So you can only reference a column. You cannot reference a cell in DAX. Okay. Then okay, that is what I just explained now. They revert to columns or tables, unlike Excel, where you can reference an individual cell. So that is what I just explained. So it is important to know that when you create a calculated column, so it can increase the size of your data model. So the disadvantage of using calculated columns is that when you have a lot of calculated columns in your project, maybe in your dashboard, so it will make that dashboard to be heavy. Okay, because you are adding columns to your model, so it will make the model to be heavy, and it can reduce the performance of the project. I'm getting that. So it is better to use measure. Okay, not advisable to use a lot of calculated columns in your project. So otherwise, you can create, if I want to create more columns, you can do that in Power Query Editor by using M language. Okay, so however, it is best to create them in the Power Query Editor, since DAX transformations occur in memory, so consuming your machine's resources. So DAX it's normally consume a lot of resources on your machine. So, but if you use Power Query, it's going to be lighter compared to using DAX to create calculated column. So then measures. So measures enable you to create complex calculations that can be used on your data. So where columns evaluate for each row to measure aggregate multiple rows and what adds a new feed that can be added to visualization. So for this measure, we use measure to calculate aggregations to get aggregate of a particular column. Okay, maybe you want to find the sum, or you want to find the average of a particular column, average of values in a column, or you want to count the number of values in a column. So that is what we use measure for. So, and you can only get a value while creating a measure. So if you create a measure, so you get a what? You get a value. But for calculated columns, so you get the number of cells you have in your data set, the number of cells in that particular column. Like now, if you want to get a calculated column, you will use existing column to get that calculated column. So the number of cells we have in that existing column will determine the number of cells, number of values that we have in calculated column. But for measure, you can only get one value. That is maybe total sales, total number of set of values in a column. So that is a difference between measure and what and calculated column. So another difference is that when you create a measure, so it won't add it to your data set. So you can only find it in the data pane. So where you will use it on the dashboard. So you can use a measure to create a dashboard. Maybe you can add measure to the dashboard, to your dashboard, but you cannot. It can't be added to the data set, unlike calculated columns. So can you see, unlike calculated columns, measures are not stored in a table. However, they are feasible when used within a visualization. So if you want to add it to your dashboard, so you can get it in the data pane and add it to your dashboard, but you cannot see it in the table. So that is measure. So that is reason measure it is more advisable to use measure compared to calculated column, because it won't increase the size of your data set. So it is calculated based on filter context. So it is more lighter than calculated column. So then we have implicit and explicit measure. So an implicit measure is a measure that is created automatically by Power BI. So I've explained that before, that if you have a numeric column in your data set, Power BI will automatically calculate the sum of the column. So you have the total values of the column in your Power BI in the data pane. So they are easy to use. Okay, so they are easy to use, but they have limited functionality compared to explicit measure. So for implicit, you have them in your data pane. So if you need them on your dashboard, just drag them to the dashboard to show the total, maybe total sales, total number of a particular value. So, but for explicit, so explicit, you can only get explicit by using a DAX formula. So an explicit measure is a measure that is created manually by the user using what? DAX formula. So they are more flexible and dynamic than implicit measure. So they can what? Reference within other DAX calculation, unlike implicit. So you cannot reference implicit measure created by the Power BI if you are creating another DAX formula. But if you have existing explicit measure, if you have it in the data pane, so if you are writing another DAX, so you can reference the existing explicit measure you have. Okay, so maybe you have created a measure, maybe you have a total, maybe total 6, and you want to get a discount. So you want to create discount measure. So you can reference that total sales that you have created with DAX before. So, but if it is implicit measure, so you cannot reference it in your calculation. So why writing the DAX formula for another measure? So you cannot reference the implicit one. But for the explicit, so you can reference that. So now, DAX contain three components: functions, operators, and what? And arguments, or you say values. So functions are what? Are predefined formulas that perform calculations or on specific values called arguments. So for example, aggregation, this is a function, sum. So this is another function, average, count, mean, max. So all these, they are what? They are function. For aggregation, so if you want to create a measure, so you can use all these to create a measure. So then we have date and time. If I want to create a measure for today, so you can use this function, today, month, year. Okay. So we have a logical function, if, and, or, text function, concatenate, upper, left. So all these, they are functions in DAX that you can use. So then filter functions, calculate, filter, or values. So now let's now check it one by one. So if I want to use sum in DAX, in Microsoft Excel, if you want to use sum, so you have equal sign, sum into bracket, A1 colon, maybe A10. Maybe I want to find the sum of 10 values in a particular column. So that is for Microsoft Excel. So, but in DAX, I told you that you cannot reference a cell. You cannot reference a cells in DAX. What you can do is to reference the table and the column. So look at this one. So we want to add all the numbers in the column. Okay. So if you want to do that, so you start with equal sign, then sum into brackets says. So this says is the data set, the name of the data set. That is table. Okay, so the name of the data set. Then now have a block brace. So this is a block brace. So then the column amount. It means I want to find the sum of the values in amount column. If it is Excel, so what you just need to do is to have sum into brackets. So maybe A1 to A5. So, but you cannot do that in DAX. So look at this average equals to average into bracket 6. Then amount into you reference the data set, then the column. But this one calculate. So if you need maybe your DAX is going to be divided into two components. Like, so you make use of calculate. When we use sum and average, so you just find the sum directly. So you find the average directly. For this one, you want to calculate the sum based on condition. Okay, so you want to calculate the sum based on you don't want to find the sum of all the numbers. So you want to filter some values and add them together. Are you getting that? So if you want to do that, so you will need this function, calculate. So you start your DAX formula with what? With calculate. Are you getting that? Because you need if you just want to find the sum, so you just start with sum. But now you want to find the sum based on condition. So now start the DAX with what? Calculate. So into brackets, then you find the sum of the column. So comma, then you now say says. So now our DAX involve two columns now. So unlike other one, so where we use just one column, that is the sum of the column, we want to find the total. But here now, we want to find the sum of a particular column based on another column. So you now use what? Calculate. Okay, equal sign, calculate into bracket. So we now have the all the formula you have for the first one. So you have it, then comma. So we use comma to separate the two. So you now say says into bracket region equals to naught. That is, we want to find the total amount based on northern region. So you want to find total amount of sales, okay? So based on another region. So that is how to calculate sum. So using a condition. So maybe you said maybe if this one is a numeric, okay? So you can use greater than, okay? Maybe you want to find a sum of amount. So where salary greater than maybe 100,000. Are you getting it? So you're going to total all the salaries, okay? So based on what? So maybe where department equals to ICT. So that means it's going to find the salary, total salary of staff in what? In ICT. So if you want to do that, what we need is what? We need this keyword, this function, calculate. But if you want to create a measure, so like that of implicit, because if, for implicit measure, so it will just calculate all the values in that column without any condition. So you don't need calculate function. But if you want to find the total of a particular column based on another column, you will need what? You will need calculate. So look at this one, filter. So filter return a table that has been filtered. So you want to find the sum, okay? So sum of amounts, okay? Then filter says, comma says, so this one, you get the same result with this and this. Says equals to naught, okay? So it's going to filter all the region in naught and calculate the sum of the amount, okay? So you get the same result with this. We're using this. So you don't use filter here. So you can have filter to this but we get the same result. Then we have if. So return one value if a condition is true and another value is false. So if sales amounts are greater than 1,000, okay, high or low. So you can use this one to create a calculated column. Okay, so you can use this to create a calculated column. So where you now have where you have this equal sign. So we are going to, if you want to create a calculated column, so I will show you. So we are going to create we create a measure and a column. So if you want to create a calculated column, we name it to maybe you call it status equals to, okay. You now have if says amount greater than 1,000. So you're going to look for those amounts that are what? Greater than 1,000. So the status will be what? I. Okay. So those that are not greater than 1,000. So the value will be what? Low. So that is a calculated column. So it's different from getting aggregate. The aggregate is okay. You want to get the average or you want to get the sum of. So for that one, you get just only one value. But this one, so we get the total number of the list of values you have in that column, in amount column. So it's going to generate values based on the value you have in amount column. Okay, so we are creating new column called status. So, and the value will be determined by the value we have in amount column. So if amount is greater than 1,000, so that means the value we have in that status is what? I. So if the value of amount is less than or equals to 1,000, so the value we get in status is what? Low. So you can visualize that status. You can plot status against maybe another column on your dashboard. So your data set will be what? Will be increased by one column. So that is calculated column. Okay. Okay. So look at this. Measure created in the feed pane. Example, total sales equals to sum into bracket sales amount. So you can only find measure in your data pane. When you load your data set, so it's going to display all the feed name, all the column in right hand side of your dashboard. So you can only find measures on feed pane. So you cannot see, you cannot find your measure on data set. So, but if it is calculated column, so apart from calculated column showing on the feed pane, you will still see it on your data set. So created by adding a new column in a table. So look at this example, profit equals to sales amount minus sales cost. So it's going to check the amount of sales, particular value in first cell in the amount column, and value in the first cell in cost column. So subtract cost from amount, you get profit. So if you have 100 values in that column, so that means you are going to get 100 values for the profit. So if you generate new column for calculated columns, but if it is measured, you just get only one value, maybe total 6. Are you getting? So we use total 6. We use measure on KPI. KPIs are all the total values are normally created at the top of the report, at top of the dashboard. So that is what we use measure for. For calculated columns, you can use it to plot charts, to plot histogram, bar chart, and some other. Do you get that? Because it will generate another column for you. So you cannot plot it against another column in that data set. But you cannot plot measure against another column because it's just a single value. So you can only display that values on the KPI, maybe percentage of sales or percentage of a particular column. Do you get that? Okay. So now, so before we move to our contest, so let's try to demonstrate measure and calculated column. So creating measure and calculated column. So I don't know why this Power BI is angry. Let me reopen it. So I want to show you how to create a measure and calculated column in Power BI using DAX. So, okay, it's opening. Okay, so let's see this. Okay, I think I use it in. Okay, let's check student enrollment. Okay, this is student enrollment. Okay.
So it's not showing.
So now let's see. You know, normal implicit measure. They are normally created by Power BI. So immediately you load your into Power BI, so you see those implicit measure on the data pane here. So I want to show you. Okay, this one. Okay, there's no any implicit. There's no any implicit measure here. But look at this. And so this figure 1,247. So it was created with measure, okay, DAX, because what we have is total enrollment. So that is what we have. But now we want to extract the total, okay, based on session. That is, we want to know in that data set, if you look at the data set, the table, you know, we have session. Okay. Okay, we have session, right? This is session. So, and in this session now, so we have 2020, 2021, 21, 22, and so on like that. Okay. But here now, we don't have numeric values. Okay, except level. So we don't have numeric values for maybe